extends the equivalent length to 2 or 3 times the length of the rocket. So you, in essence, have a very long wire, and in the strong field of perhaps 10, 20, 30,000 volts per meter over 400 meters, you can generate something of the equivalent of 1 million volts. So you get a discharge then through the rocket, the plume, and that triggers the lightning. Well, in the worst case, it could actually potentially blow the rocket up.
When a mystery flash was filmed in 1989, NASA had reason to fear a new form of lightning that could blow up a rocket high above the clouds. NASA asked Skeet Vaughn to find evidence that the phenomenon was real. He searched for similar flashes in NASA's archive of storms filmed from Earth's orbit.
When we were back looking through the tapes, we were able to go through probably 17 or 20 hours of tapes. And in those tapes, you have to go through each video frame, and then you have to identify the video frame and what's on that tape, and then try to compare it with what you know should be out there.
By 1992, the detective work had turned up startling images. They showed the edge of the Earth. Bright columns fired upwards 70 kilometers from the clouds, towering over the horizon.
We found a total of probably 19 of those things on different shuttle flights over time.
NASA feared they might be more dangerous than the ordinary lightning that had previously hit their rocket. A race began to find out if these were giant bolts and if they could bring down the space shuttle. NASA turned to Walt Lyons, a world expert in the detection of distant lightning strikes. NASA had used his skills to make launches safer after the 1987 disaster. Their rocket safety team now shared their concerns over the new discovery.
When it appeared that there was this whole new form of lightning, not coming down but going up, naturally the safety people were concerned, and they said, we better find out about this.
Walt Lyons' observatory on Yucca Ridge was perfect for hunting lightning. Colorado's clear skies offered views above storms over 1,000 kilometers away in Tornado Alley, the prairie states hit by the worst of the 20 million lightning bolts that strike the United States each year.
Well, being here on the lip of the prairie, we're at the highest point on the plains, and it's basically downhill for 1,000 kilometers from here. This is what they used to call the Great American Desert, and it's essentially flat.
NASA gave Lyons the job to film above storms to see if the mystery flashes might be a threat. He ordered a remote camera to set up on top of his observatory.
This very camera here came on the day of 6 July 1993. We took it out of the box, and that very evening, there was a massive thunderstorm going on out in Kansas, about 300 kilometers away, and it was just lighting up the whole sky, and I said, aha, this looks good. So I just sat and waited.
Lyons linked the camera back to the video recorder in his viewing room.
11 o'clock, and it was really fun to watch the lightning, on this video enhancement image, and looking at it, and that's impressive, that's nice. $12 o'clock, yeah, that's nice. 1 o'clock, it's nice, but not much was happening.
Lyons was weary from monitoring the storm when he suddenly saw flashes that did not behave like ordinary lightning.
Then bing! I saw something on the screen. I said, what was that? About a minute later, another bing! And I said, oh boy. By the time the sun came up around 4:30, we had seen 250 of these bings. We just picked the right night with the big storm in the perfect location, and it was classic beginner's luck.
In one night, Walt Lyons had proved the phenomenon was real, but it still had no name.
A friend had suggested calling them sprites, which shows up in several Shakespeare's plays. And I said, that's a beautiful name, that's perfect, because it's sort of a fleeting, ephemeral type of creature, and it doesn't imply something about the physics.
A year after Walt Lyons' discovery, a University of Alaska team set out to photograph the sprites from the air, up close and in colour. Student Matt Hevner volunteered for the mission.
They basically needed somebody to operate the cameras and hit record on the VCRs and figure out, where to fly, things like that.
The flights took place on the night of America's 4th of July celebrations.
In terms of dangers that may be associated with the sprites, well, since we were going to be in airplanes flying around the storms, was there any danger to us? And in general, the pilots were even more worried about that than we were. So we trusted their judgment to keep us far enough from the storms that we weren't in danger.
As the fireworks exploded below, Matt Hevner's camera captured what no one had seen before. The sprites were coloured a vivid blood red.
There were a few storms where we were seeing sprites maybe 3 or 4 times a minute, and so that was pretty exciting.
In one night, the lightning hunters had bagged hundreds of images that had revealed the true colour of sprites. They were red and blue neon-type glows, a sign they might be explosions of electricity, exciting gases in the high atmosphere. From the ground observatory at Colorado, Walt Lyons filmed another peculiarity. The sprites appeared to be dancing across the cloud tops.
What we're seeing here is a discharge inside the cloud, and then the sprites are just dancing along and more or less following that discharge.
But were they just a trick of the light? Ordinary lightning gave warning of its power with the sound of thunder. If sprites made a similar sound, it would prove them to be more than a mirage.
Sprite is very impulsive, boom, like that, which means a lot of air is potentially being heated or pushed around. So I wondered, could there be some analogy to thunder produced by a sprite?
Dr. Alfred Bedard, who would hunt for sprite thunder, had been a guardian of world security during the Cold War.
If the communist bloc does attack, our radar sites and observers will sound the alert.
Dr. Bedard's audio array near Boulder, Colorado, can hear the frequencies undetectable by human ears called infrasound. Until the advent of satellites, his system was the main warning of rogue atom bomb tests. He can detect sound from the other side of the world. If he could measure infrasound from sprites, it would show they had enough power to fire out on the same spectrum as an atom bomb.
We detected sounds from sprites. These were detected at here in Boulder.
Dr. Bedard can hear the subaudible sound of the sprite by playing it back through a program in his computer.
There's a very loud, vicious sounding rumbling, and all of this is subaudible again, but when you play it back at high speeds, you wouldn't want to get near something like that.
No communist atom bomb had escaped Dr. Bedard's infrasonic array. Now red sprites might be tracked far away, even those that flashed during daylight hours. The sprites could be heard. They needed to be examined in greater detail. Professor Umran Inan, a leading physicist of Stanford University, would unleash his